All right, ladies and gents, Bellringer 7 and 8 for today. Number 7 says write the equation that is perpendicular to 15x minus 3y equals 39 and passes through the point 7, 12. Okay? Key thing, we're looking for perpendicular and passing through the point 7, 12. You're given the equation 15x minus 3y equals 39. Okay? Now, to find the perpendicular line, okay? Perpendicular means you have the opposite and flipped slope. So opposite and flipped. Now, looking at the equation, it is in standard form, so you cannot readily see the slope that they gave you. So you're going to have to do a little work. There's two ways you can do it. One, you can solve for y. Or two, you can use the equations that we talked about when we first started talking about perpendicular and parallel lines of standard form. Now, I'm going to go ahead and do the solving for y method. If you want to use the equations, be my guest. Should give you the same answer. Okay, so we're going to solve for y real quick. I'm going to subtract 15x, negative 3y equals negative 15x plus 39. Divide by negative 3, divide by negative 3, divide by negative 3. Again, because the plus sign means you have to separate both of them. Cancels out. Y equals negative 15 divided by negative 3 gives you 5x minus 13. Okay? Just divided those real quick. Okay, you have a negative because you have two different signs. So that equation is the same as that equation. Okay, this is not your answer. This is what you're going to find your perpendicular line from. All right, so our slope for our perpendicular line has to take this slope, flip it, and switch it. Okay, so our new slope is going to be, instead of positive, it's going to be negative. And instead of 5, it's going to be 1 over 5. So that is our perpendicular slope that we're going to be using. Okay? Now, once we've solved for y, we have our new slope. So what we're going to do is we're going to create our new line. Okay? Your new line has to pass through that point. So we have a slope, we have a point, so you're going to use point-slope form. Y minus y1 is equal to mx minus x1. Y minus 12 is equal to your slope, which is negative 1 over 5. And we've got x minus 7. Okay, all I did was I plugged in your new stuff, the perpendicular slope and the point we're passing through. From here, solve for y. Okay, so we have y minus 12 is equal to negative 1 over 5x plus 7 over 5. Again, to multiply a fraction times a whole number, multiply the whole number by the top. Negative times a negative is a positive. Alright, keep solving for y. We have to add that 12. Add the 12. Y is equal to negative 1 over 5x. And I cannot do 7/5 plus 12 in my head, so I'm going to use a calculator. We got 7 over 5 plus 12. Gives you 13.4, okay, but I would like you to turn that into a fraction. Ends up as positive 67 over 5. When you get ready to put this into your answer document for your Bellringer, if you'll just put in 67 divided by 5, that'll work. Okay, 65/5, or 67/5. All right, so there's your answer to number 7. Okay. Number 8 says find the distance of the line with endpoints 3, 2 and negative 18, 7. All right, so most of you are probably forgotten. But your distance formula, okay, is the square root. Is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, you got to do all of it. It's not super complicated, guys. Just fill in your numbers. All right. So over here we've got x1, y1, x2, y2. Plug in your numbers. x2 we have as 18, sorry, negative 18. Negative 18 minus 3, and that's squared, plus y2, which is 7 minus 2 squared. Okay, if you have a calculator that can do that, great, do it. But me personally, I like to do it step by step before I try to put it into a calculator, because sometimes that putting it in all that information you can mess up really easy. Okay, so again we have the square root. Negative 18 minus 3 gives you negative 21 squared, plus 7 minus 2 gives you 5 squared. Okay, just keep doing your work. Negative 21 squared gives you 441 plus 25, which gives you the square root of 466. Simplify if you can. Okay, run through all of your perfect squares. If you take a couple seconds to do that, you will notice that there are not any perfect squares that go into 466. So, you cannot simplify it any further, and you end up with the square root of 466. Alright, ladies and gentlemen, I'll see y'all tomorrow. Make sure you're working on your linear art. When you get done, submit it to me. Same thing with your bell ringers. Make sure you're working every day. Adios, amigos.